Hello everyone, this is Rajesh. I'm going to explain the introduction of Hive. Hive is basically a data warehousing tool for managing and querying structured data for Hadoop data file systems. Initially, Hive was developed by Facebook and later it was taken over by Apache Foundation who developed it as an open source. Hive is a tool used to develop SQL type scripts for structured MapReduce operations. It stores schema in a database and the process data is stored in HDFS. It's basically an online analytical processing tool. Hive basically uses a SQL type language called HiveQL or HQL. Hive is scalable and extensible. Moving on to the next slide. This diagram over here is the architecture of Hive. The user interface of Hive is for the interaction for the user with the HDFS. The interaction takes place through Hive Web UI, Hive Command Line, or Hive HD Insight, and the Metastore is used to store the schema and metadata of tables and database columns in a table, their data types, and HDFS mappings. The HiveQL process engine, like HiveQL, is similar to SQL for querying on schema info on the Metastore. It is one of the replacements for the traditional approach for MapReduce program. Instead of writing MapReduce program in Java, we can write a query for MapReduce job and process it. The execution engine, the conjunction part of HiveQL process engine and MapReduce engine is Hive execution engine. Execution engine processes the query and generates the result as same as MapReduce results. It uses the flavor of MapReduce. And at last, HDFS or HBase, Hadoop distributed file system or HBase, are the data storage techniques to store data into the file system. Moving on, the question, what do Hive queries look like? I already told that HiveQL is pretty much similar to SQL. There are a few differences. Like HiveQL supports 9 data types while SQL has only 5. And also HiveQL supports all select command subqueries joined similar to SQL.
Hello everyone, my name is Sneha Chilmula, and here I'll be talking about the workflow of how Hive interacts with the Hadoop framework. First, the Hive interface sends the query to the driver to execute. Next, the driver helps, with the help of the query compiler, analyzes the query and checks for syntax and its requirements. Step 3, the compiler sends the metadata request to the Metastore. Step 4, the Metastore sends the metadata as a response back to the compiler. Next, the compiler checks the requirements and resends the plan to the driver. At this point, the compiling of the query has finished. Next, the driver sends the execute plan to the execution engine. And step 7 is execute job, which is the MapReduce job. Step 8, the execution engine receives the results from the data nodes. Step 9 and 10 are execution engine sending the results to the driver and the driver sending the results to the Hive interface. Now moving to the next slide, I'll be talking about the differences between Hive and HBase. Hive is not a database, whereas HBase supports a NoSQL database. Hive supports batch processing, whereas HBase supports real-time processing. Next, Hive has a schema model, whereas HBase is free from the schema model. Last, Hive runs on top of Hadoop, whereas HBase runs on top of HDFS. And Hive uses Hive QL, which is a SQL-like query capabilities, and HBase does not use SQL. Moving to my question, when can Hive not be used? Hive is not designed for OLTP. It cannot be used for real-time updates or queries, and it cannot be used for scenarios where low latency of data retrieval is expected, as there's a latency in converting the Hive scripts into MapReduce scripts. That's it.
So my name is Freyank and I'll give an introduction to Zookeeper. So Zookeeper is it's a service for distributed systems which offers a hierarchical key value store. It is used to provide distributed configuration services, synchronization service, and a naming registry for large distributed systems. Okay. So Zookeeper was initially built at Yahoo for accessing their applications in a robust manner. It is a distributed coordination service which manages a large set of hosts. Um, so as we all know that coordinating and managing a service in a large distributed environment is pretty complicated, as it involves like a lot of locks and whatnot to like hold on to the data. So Zookeeper solves this issue with its simple architecture and API, which we'll discuss in the next slide. So Zookeeper allows the developers to focus on like core application logic without having to think about the underlying distributed nature, since all of it is managed to the APIs. Zookeeper became like a standard service which was used by Hadoop and HBase and like many other distributed frameworks to keep track of distributed data. So to discuss the architecture of Zookeeper, it is basically a distributed application on its own, but also it is a coordination service for the distributed system itself. So it has a simple client-server model in which all the clients and the servers are nodes. So Zookeeper clients make use of the services which the servers provide as the services. The applications on the clients make calls to the Zookeeper through the API, through the client library, and the library handles all the interactions with the Zookeeper servers. Okay, so it could be run in like two modes: standalone and quorum mode. So in standalone mode, the Zookeeper service is sorry. So in standalone mode, the Zookeeper service is on a single server, and it is like it is not replicated anywhere. But in quorum mode, a group of Zookeeper servers are made, and it is also known as a Zookeeper ensemble, and it replicates the state across all the servers. Saurabh now will demonstrate the features of Zookeeper.
My name is Saurabh, and I'll take over the topic of Zookeeper from here. I'll be discussing the features of Zookeeper. The first feature is it has a very simple architecture. So Zookeeper has a very simple client-server model in which the clients are nodes and the servers are also nodes. Applications make call to the Zookeeper through a client library, and the client library handles the interaction with the Zookeeper and servers. Second feature is a reliable system. So Zookeeper has a very reliable system, as the failure of one or few systems does not make the whole system to fail. Third feature is scalable. Zookeeper is the scalability factor of Zookeeper is very high, as the performance can be increased as and when needed by adding more machines with minor change in configurations of the application with no downtime. A fourth feature is fast processing. Zookeeper is very fast, especially fast in read-dominant workloads. Zookeeper applications run on thousands of machines, and it performs best where read operations are common than write operations at the ratio of around 10:1. Next slide, please. Here we'll take one question on the topic of Zookeeper. So what is a Zookeeper ensemble? When you want to have very high availability in Zookeeper server, you use a multiple Zookeeper servers to create an ensemble. Basically, the Zookeeper ensemble is an array of nodes. It has a master and slave architecture. In a Zookeeper ensemble, there will be one master and the rest will be slaves. If the master fails, one of the slaves will act as a master. That's it. Thank you.
Okay. So thank you,